Have you ever stopped to think about the invisible toolkit you use like every single day? It's this secret science, chemistry, working behind the scenes in your medicine cabinet, in your kitchen, solving all these little problems you might not even realize you have. So, let me ask you a question. It kind of sounds like the start of a weird joke, but here it is. What do aspirin and jam have in common? Seriously. The answer is actually incredible, and it connects two totally different parts of our daily lives. Stick with me, you're gonna want to hear this. All right, to get to that answer, we're going to start our journey inside the human body. We'll look at the super clever chemistry we use to fight back when we're just not feeling great. First up, that classic trio: pain, fever, and infection. Okay, before we dive in, let's get one thing straight. We throw around the words drug and medicine all the time, right? But they're not exactly the same thing. A drug is really any substance that has an effect on the body. But a medicine, well, a medicine is a drug with a mission. It's designed to create a helpful, therapeutic effect. So think of it this way. All medicines are drugs, but not every drug is a medicine. So let's talk about one of the most common problems we all deal with. You know it well, that tag team of pain and fever. They're basically your body's alarm bells, and lucky for us, chemistry has a solution. And this is where the chemistry gets really, really cool. Because these things aren't just one-trick ponies. Chemicals like aspirin and paracetamol are amazing multitaskers. They're analgesics, which is the fancy word for pain relievers, and they're antipyretics, which means they reduce fevers. It's just a perfect example of chemical efficiency, right? Two problems, one single, elegant solution. But what happens when the problem is bigger than just a symptom like pain? What if it's a full-on invasion? Yeah, now we're talking about bacterial infections. And for that, you need a totally different kind of chemical weapon. This is when we call in the heavy artillery, antibiotics. Their mission is so precise, it's incredible. They are programmed to hunt down and destroy the harmful bacteria that are making us sick, while leaving our own body cells totally alone. It's literally a microscopic search and destroy mission. And get this, they don't all fight the same way. They have different strategies. You've got some, like penicillin, that are basically demolition experts. They attack the bacteria's protective outer wall until it just falls apart. Then you have others that are more like saboteurs. Erythromycin, for instance, it sneaks inside and shuts down the bacteria's protein factories, just grinding the whole operation to a halt. Okay, so we've seen how chemistry defends us from the inside out, but, the fight against microbes is also happening all around us, on the surfaces we touch every single day, from kitchen counters to our own skin. Now, here's one of those things that trips a lot of people up: antiseptics versus disinfectant. They both fight germs, right? But the key difference is the battlefield. Antiseptics are for living tissue, like a cut on your hand. Disinfectants are for non-living things, like a doorknob. Same goal, but totally different rules of engagement. And to really see why this is so important, let's just look at one chemical, phenol. At a super, super low concentration, we're talking just 0.2%, it's an antiseptic. It's gentle enough to use on skin. But watch what happens when we just nudge that concentration up a little bit to 1%. That exact same chemical, phenol, becomes a powerful disinfectant. Now, it's way too harsh for our skin, but it's perfect for cleaning a countertop. It's just an amazing reminder that in chemistry, the dose really does make the poison, or in this case, the cleaner. All right, let's switch gears. We're leaving the medicine cabinet and heading into the kitchen. Because these same exact principles of chemistry are hard at work in there too, in the constant battle to keep our food safe and fresh. Now, the secret weapons in the kitchen are called food additives. I know, that term can sound a little intimidating, but all it really means is something that's added to food for a specific purpose. It might be to improve the flavor or color, but for our story today, the most important job is to stop that food from going bad. So, enemy number one in the kitchen is just simple spoilage. This is what's happening when all those little microorganisms like bacteria and fungi start breaking down our food. So how do we fight back? With preservatives. Their job is to basically hit the brakes on those microbes, slowing down or even stopping the whole decay process. And you use them all the time without even thinking about it. Acetic acid, for example, is just the scientific name for the main ingredient in vinegar. But microbes aren't the only enemy out there. There's a much sneakier attacker, especially for foods that have a lot of fats and oils like chips or salad dressing. It's a chemical process called oxidation, and you definitely know its telltale stale smell. It's what makes food go rancid. And to fight oxidation, we need a totally different kind of chemical defender, the antioxidant. Its one and only job is to stand guard and slow down that oxidative decay, keeping our food from going stale and tasting gross. So how on earth do they do that? Well, this breaks it down perfectly. The process of oxidation creates these really unstable molecules called free radicals, and they start a damaging chain reaction. What the antioxidant does is it heroically jumps in the way, sacrifices itself by reacting with that free radical, and boom, the chain reaction is stopped dead in its tracks, and the food is protected. Pretty cool, right? And I absolutely guarantee you have seen these guys in action. Next time you grab a box of crackers or a bag of chips, flip it over and look at the ingredients. You'll see names like BHT, BHA, or sulfites. Those aren't scary chemicals. They are literally the bodyguards on duty, keeping your food fresh. So, when you step back and look at it all, from fighting a simple headache to keeping your jam from getting moldy, chemistry gives us this incredible, targeted toolkit for solving the problems of everyday life. Which brings us all the way back to that first riddle. So, what do aspirin and jam have in common? Well, the answer is actually so simple and elegant. They are both perfect examples of targeted chemistry. Aspirin is a chemical tool that targets pain and fever in our bodies. The preservatives in jam are chemical tools that target the microbes that cause spoilage. Two totally different problems, two completely different targets, but the exact same brilliant principle at work. So, what are the big ideas to take away from our little tour of the chemical toolkit? First, just remember that chemicals are simply tools designed for specific jobs. Second, that some of these tools, like aspirin, are amazing multitaskers. Third, and this one is huge, concentration is everything. It can completely change what a chemical does. And finally, that the same chemistry is what's working around the clock to keep our food supply safe and fresh. And that's really the heart of it. This invisible toolkit is all around you, all the time. So the next time you're wandering through a supermarket or just looking in your medicine cabinet, I want you to ask yourself this question. Now that you've seen the science behind it, which label will you look at differently? Because that science is everywhere once you know how to see it.